And we are in Module 8, and now we're going to Module 8b. The last time I saw you, we were working on systems of linear equations. Remember, a system means we don't have one equation now, we have two. Well, today's lesson, we're not going to have two equations, we're going to have three equations. So we're going to be doing a linear system. It's still going to have x and y to the first power. But because we're going to have three equations, we're going to throw in another variable. We're going to have the variable z to the first power. So let's take a look at our notes. So if you look here, the definition says a linear equation in three variables looks like the form ax plus by plus cz equals d. So you're going to have three variables, x, y, and z, and there's going to be some numbers in front of them. What's going to happen is when we solve this system, we're going to have to get an answer for x, an answer for y, and an answer for z. And that's called an ordered triple. So before we even go and solve one, let's make sure we understand what we're doing. So let's go up to the whiteboard. Okay, everybody. This is what we call a linear system with three variables. Each equation has an x, a y, and a z. Also, each variable is only to the first power. So these are still linear. And what we're going to do here is solve. We're going to get one answer for x, one answer for y, one answer for z, because that's what linear means. Before we actually go solve, let's just review. How do you know if this ordered triple is the solution, the answer, without having to work all this out the long way? Well, we know the first number represents the x, the second is the y, and the third is the z. And before we ever want to actually work all this out and find out if those are the answers, what can we do with those values? That's right. We could just do simple substitution. In every equation, we can replace x with -1, y with 2, and z with -2, and see if it balances. Because if that truly is the solution, the point of intersection, then that system, this ordered triple, should work for all three equations. So let's see if it does. So let's rewrite this. Instead of writing x, we're going to write -1 plus 2. Instead of writing y, we're going to write 2 minus 3. Instead of writing z, we're going to write -2. And we're going to see if that equals 9. Now we're going to do our arithmetic skills. Well, that's -1. 2 times 2 is 4. -3 times -2 is +6. Does that equal 9? Sure it does. 4 and 6 is 10. 10 minus 1 is 9. That checks. That doesn't mean it's the solution. A solution means it works in all the equations. So let's do the next one. We have a 2. Instead of writing x, we're going to write -1. We write the minus. Instead of writing y, we're going to write 2 plus 2. And for the z, we're going to write -2. And we want to know if that equals -8. Now we'll do our arithmetic. 2 times -1 is -2. This is a -2. 2 times -2 is -4. Does that equal -8? Well, all three negative numbers are negative, so that's right. You would add them. -2 and -2 add to -4. -4 and -4 adds to -8. That checks. But it's still not the solution until you're guaranteed it works in the whole system. So we've got to check the third equation. So instead of having x, we're going to have -1. We're going to write +3. Instead of writing y, we're going to write 2. -4. Instead of writing z, we're going to write -2. And does that equal 15? Let's try again. We're going to leave the -1. 3 times 2 is 6. -4 times -2 is +8. And does that equal 15? Remember, it doesn't matter what order you add and subtract, we're all going to get the same result. I see 6 and 8 adds to 14. 14 minus 1 is 13. 13 does not equal 15. If you want to add the numbers in order, that's fine. -1 plus 6 is 5, because you would subtract, signs are different. 5 plus 8 is still 13. 13 doesn't equal 15. So because this ordered triple isn't a solution for the third equation, it is not a solution for this system. And it's very important we understand that. When we solve a system, the answer you get for the variables has to work for every equation. Now, there's no way you guys could graph this because it has 3 variables. You've never graphed with 3 axes. You've only graphed on the x-axis and y-axis. To graph this would be higher math. It would be calculus. Well, don't worry. We don't want you to do calculus in college algebra. So the only way we can get the solution is to teach you how to solve it. So let's go back to the notes for a minute and look at the procedure. Okay, so if we go to our notes, there is a procedure to solve a system of 3. The hard part is understanding what we're going to do here. You have 2 methods to solve we reviewed in Module 8A. You had substitution and the addition method. In this case, when you have 3 equations, there is a better decision. And the better decision, believe it or not, is to do the addition method. It's much easier to add the equations than try to get a variable alone and do substitution. But if you look at the notes, it says you're not adding all 3 equations together. You can only add 2 at a time. And again, this is where the problem's going to be. Not everybody has to add the same 2 equations first. It doesn't matter what order, we all should get the same result. So, we're going to go to the whiteboard now. This is going to take a page of loose leaf. It's going to take some work. Okay, here is my system of 3. I want to solve it. I actually want to know what x, y, and z are as numbers. You cannot do substitution here. It'd be a way mess. The easiest method is to do the addition method. But you can't just add all 3 equations because the goal of addition is to make something cancel. Think about this. If I had an apple and I subtracted an apple and then I had another apple, would the apples be gone? No. These would, but you'll still be left with the at. That is why you cannot just add all 3 equations at once. So you're going to have to pick 2 to add. Now, this is my first suggestion. This takes organization. So what I tell everybody in my class to do is name these equations A, B, and C. What your goal is to get a variable to eliminate. So the best thing to do, guys, is look with your eyes. Look at the 3 equations and see, do you have a variable that will eliminate that if you add it with the other equation will be gone? Well, none of the x's are opposites. None of the y's are opposites. But if you look closely, isn't this negative z and this positive z opposites? So if you put these together by adding, wouldn't they cancel? That's what you're looking for. You're looking to find 2 equations that you know when you add them, a variable will cancel. So we're going to take equation A and add it to equation B. And I'm writing it down so I know what I'm doing. So the first thing I'm going to do is copy them correctly. X plus 4y minus z equals 20. 3x plus 2y plus z equals 8. Because you already have your additive inverse, your opposite, you know that these are opposites, we'll go ahead and add. X and 3x is 4x. 4y plus 2y is 6y. Negative z and positive z make 0. 20 and 8 is 28. Now, I want you to appreciate what you've just done. You just went from having 3 variables, x, y, and z, to just having an x and a y. I know you don't have an answer yet because you just don't have a number. You don't have x equals or y equals, but you got down to 2 variables. Now, here's the catch. You're going to do this same procedure again. You're going to pick 2 equations. You have to eliminate the same variable z. So we've already put A and B together. So now the choice is, do you want to put B and C together to eliminate the z's? Or do you want to put A and C together to eliminate the z's? The most important thing you have to decide is putting the other 2 equations together that will eliminate the same letter. If you don't eliminate the z, you're going to be like a dog chasing your tail, going around in circles. To do this process, you must eliminate the same variable. So it doesn't matter to me if we put together B and C or A and C. Now, I'm all about making good decisions. If I want the z's to eliminate, I want one to be positive and the other one to be negative. So if you look closely, equation A has a negative z and equation C has a positive z. Those are the two I'm going to put together. So I'm going to write that. I'm going to put A with C. So let's take A and write it down. Let's take C and write it down. Now, right now, if you look at those two equations that I picked, A and C, which are different than the first two I picked, will the z's eliminate right away? Nope, they won't. What's the coefficient in front of this z? Very good. It's a 1. That's a 1 and that's a 2. They're not going to eliminate yet. They both have to be the same coefficient. Well, 1 and 2 is easy. What do they have in common? They have 2. So we're going to have to take this top equation and multiply it by 2. So there's what we're using that you already reviewed in Algebra 1. If you don't eliminate right away, you can use multiplication to get the number you need. But remember, you got to multiply that 2 to everybody. So this is going to become 2x plus 8y minus 2z equals 40. Now if you look, here's your new equation A in red. Here's your equation C. Now your z's will eliminate. So we can add these together. 2x and 2x is 4x. Negative 3y plus 8y is positive 5y. The z's cancel. Negative 16 and 40 would subtract to make 24. Again, you've done a major accomplishment. You went from having 3 variables to 2. Now guys, you're back to what we did in Module 8a. If this equation has 2 variables and this equation has 2 variables, that's what you're going to do. You're going to put them together now and do elimination one more time to get an answer. So that's the goal. After you get your 2 equations down to 2 variables, you're going to take them and put them together. Again, you're going to make a decision now. Who's going to be easier to make opposite, the x's or the y's? Well, that's obvious. That's a 4x and that's a 4x. They're easy to make opposite. One of them would just have to be negative. So you'd have to multiply by what number? Very good. You multiply by negative 1. Does it matter which equation I multiply by negative 1? Nope. I'm going to multiply this one. So I'm going to write my first one, 4x plus 6y equals 28. I'm going to multiply through by negative 1. Negative 4x, negative 5y equals negative 24. Look at that. The x's are gone. 6y minus 5y is y. 28 minus 24 is 4. That's how you get the first solution. So let's go through that again. How many equations were up here? 3. You can't add all 3 together at once. You pick 2. Why did we pick A and B first? Because the z's were opposites and we knew if we added them they would cancel. Then we had to pick 2 more equations and make sure what variable canceled? That's right, the z's again. So we picked C because it had a positive 2z. We picked A because it had a negative 1z, and we made these opposites, so that would cancel. Then you're going to take your 2 solutions, your 2 equations now that you got, add them together, make a variable cancel. The z's are gone, so now you get to choose x's or y's. Now, are we done doing our work? Oh, no way. Look, we only got an answer for y. We want an answer for x, y, and z. So let me ask you a question. Can you take y as 4 and put it back up here and get an answer yet? No, because you put y as 4 here, you'll still have 2 variables. You can only solve an equation with 1 variable. So you're going to backtrack. Now that you got y as 4, we either can go back to this equation that just has an x and a y, or this equation that has an x and a y. Because if we know what y is, we can get x. It doesn't matter which one of these we go back to, just pick one. So I'm going to go to this one. I'm going to take 4x plus 5y equals 24. I'm going to replace y with 4. That's substituting. I'm going to multiply. I'm going to get 20. Look at this. I'm going to subtract 20. I'm going to get 4y equals 4. I'm going to divide by 4, get what x equals 1. So that's important. If you know a number, you can go into an equation that has two variables, do your substitution, and get an answer. Are you done yet? No, I told you you're going to use a lot of paper. Now that you know y and x, where do you go back to get z? That's right. You go back to one of these originals. It doesn't matter which original you pick. All three will get the same value. Pick whichever one you like better. I'm just going to be a creature of habit. I'm going to pick the top one. So, I know x is 1. All right, let me find some room here. Told you you're going to use a lot of paper. So if x is 1, 1 plus 4, we know y is 4, minus z equals 20. 1 plus 16 minus z equals 20. 1 plus 16 is 17 minus z equals 20. I'm going to subtract 17, negative z equals 3. Can you have a negative z? Very good, no. You have to divide by negative 1. Z equals negative 3. There are your three solutions. When you go to write your solution down, what you really have found is an intersection point on an x, y, and z axis. That's a three-dimensional shape. You'll never graph that in college algebra, but that's what you found, where a three-dimensional shape would intersect. So when you write your final answer, it has to be written as an ordered triple. So you still put parentheses. X still goes first, 1. Y is still second, and then z goes last. It's not a hard process. It's exactly what we did a minute ago with two equations. It's just longer. And yes, I agree with you. There's a lot more places you can make a boo-boo, a mistake, and mess the whole thing up. Okay, you want to try another one? Let's try another one. Let's erase all this. All right, let's get another one. See, here's our second example. X plus y plus 2z equals 11. X plus y plus 3z equals 14. X plus 2y minus z equals 5. All right, you have a system of three equations. That is why you have three variables. Okay, the best suggestion I can do for you is to be neat and organized. I always label mine A, B, and C. Okay, here we go. You can only add two equations together. It does not matter which two equations you add first. But look at me. You want to make this easy on yourself. You want to see if there's an equation where a variable is an opposite that will cancel. So are the x's opposites? Nope, they're all x's. They're all positive. Are the y's opposite? Nope, they're all positive y's. Are the z's opposite? Well, you have to be careful. That's a positive 2z. That's a negative 1z. So even though they have a plus and a minus, they're not opposite yet. Now, it doesn't matter what variable you decide to make opposite. It doesn't matter if you want to make the x's opposite, the y's opposite, the z's opposite. It doesn't matter. Just make a decision. I bet you most of you are going to look at the z's and say, all right, let's make them opposite. If that's a 2 and that's a 1, we need them both to be 2's. If this was positive 2z and this would be negative 2z, it would cancel. You agree with me? I agree with that. Now, here's where my 23 years of math come in. I'm telling you, that's okay decision, but there's a better decision. I think it's even easier not to make the z's opposites, because to make this z opposite, you'd have to multiply everybody by 2. I'm not going to do that. Wouldn't it be easier to make the x's opposite? Because if you look closely, if that's a positive x That could be a what? A negative x. It doesn't matter which ones you decide to make opposite, but I think the x's would be a lot easier. But it doesn't matter again. Okay, it doesn't matter. Okay, so you can make the x's opposite, you can make the y's opposite, you can make the z's opposite. You can make these y's opposite, this could stay positive, and you can make this negative by multiplying by -1. It's whatever you like. Okay, we're going to go with the z's because we saw those first. So if this is positive 2z, we want to make this negative 2z. The first thing I'm going to write down is I'm working with equation A and C. A I'm going to leave. Here's A. And here's equation C. I'm going to write down. You just told me to make these z's opposite, there would have to be the number 2 here. So we're going to multiply by 2. So that's going to make that equation 2x plus 4y minus 2z equals 10. The other equation, the A equation, I'm going to leave alone. And now I'm going to add. 2x and x is 3x. 4y plus y is 5y. The z's are going to cancel out. 10 and 11 is 21. You've done a good thing. You went from having 3 variables to having 2. Now what do? That's right. You do the same process over. You pick 2 different equations, but here's the important thing. You got to eliminate who? The z's. So let's look. We've already used A and C, so they can't be combined again. So the decision is, do you want to use A and B and make the z's cancel? Or B and C and make the z's cancel? Now there is a better decision here. The better decision is to use the B and the C. Because this 3 is positive, this is negative. It's halfway there. If that's a positive 3, we need this to be a negative 3. And then they would cancel. So let's write equation B. Let's write equation C. And again, to make the z, the same letter has to cancel. You want to multiply this by 3. So we're going to distribute 3x plus 6y minus 3z equals 15. Equation B is fine, just the way it is. So we're going to copy it. All right, we're going to add these up. 3x and x is 4x. 6y and y is 7y. The z's make 0. 15 and 14 is 29. You've done a great thing. You went from 3 variables to 2. Now what do? That's right. You take your 2 answers and you put them together. This equation has an x and a y. This equation has an x and a y. All you got to do is decide who's easier to cancel, the x or the y. It doesn't matter. Okay, I'm going to cancel the x because they're smaller numbers. I got a 4 and a 3. What common number does 4 and 3 have in common? That's right, 4 and 3, their common number is 12. So to make this a 12, I'd have to multiply it all by 3. So I'd get 12x plus 7y times 3 is 21y. Oh my, we're going to do some big multiplication here. 3 times 29. 3 times 29, well 3 times 20 is 60. 3 times 9 is 27. 60 and 27 is 87. Now, we want to cancel the x's, so we want the x to be a 12. We're going to have to multiply 3 to 4, but we want this to be negative, so we're going to multiply by negative 4. So negative 4 times 3x is negative 12x. Negative 4 times 5y is negative 20y. Negative 4 times 21. 4 times 20 is 80. 4 times 1 is 4, so that's negative 84. And look what happens. The x's cancel. 21y minus 20y is y. 87 minus 84 is 3. And there's your first solution. So, the hardest part of this whole process is you thinking. Are we done? No, we're not done. We got y, so now where do you go? Do you go back to the originals? You can't yet. If you only know one number, we're still going to have two variables. That's not going to work. So you backtrack. If you know y, you either go to this equation with an x and a y or this equation with x and y to find the next one. I'm going to pick the easy one. 3x plus 5y is 21. So I'm going to write that down. I'm running out of room here. I know we use a lot of room here. So here we go. We have 3x plus 5y equals 21. We found out y is 3. So 3x plus 5 times 3 equals 21. 5 times 3 is 15 equals 21. We subtract 15, we subtract 15. 3x equals 6. We divide by 3, we divide by 3. X equals 2. All right, 2 down, 1 to go. Now that you have two variables, x and y, yes, now you can go back to any of the originals to get the z. Does not matter which one, pick one you like. I'm a creature of habit. I usually pick the top one unless it was ugly numbers. So I'm going to pick the top one. So erase this, and here we go. We got x is 2, so a 2 goes in that spot. Plus, we got y is 3, so a 3 goes in this spot. Plus 2z equals 11. Collect like terms. 2 and 3 is 5. Plus 2z equals 11. Subtract 5 from both sides. 2z equals 6. Divide by 2, divide by 2. Z is 3. Now, how do you write your final solution? As an ordered triplet. Who goes first in our ordered triple? X is 2. Then y is 3. Then z is 3. There's your solution set. That's a lot of work. I know that. But it's showing you, if you know your basic skills of Algebra 1, solving just a linear system with x and y, you can solve anything. You're just going more in depth. You think you can try one more? Let's just try one more, okay? I know it's a lot of work, but let's just try one more. We got to get good at this. All right, so our last system of 3. We have negative 4x minus 3y equals 0. 3y plus z equals negative 1. 4x minus z equals 12. Now I know what you're thinking. You're thinking, hey, Miss Black, where are all 3 variables in all 3 equations? Okay, even though you don't see the x, y, and z in all of them, they're there. They're understood to be zeros. This is still a system of 3 because you have 3 different variables. You have an x, you have a y. Well, there's no z, so that would be 0 z's. This has a y and a z, it has no x, so there's a 0x. Now, we're not going to write the zeros in because we know 0 means there's nothing there. We're still going to do the same process. You have 3 equations here. Your job is to pick 2. Pick the 2 where a variable you know is going to cancel. Look with your eyes. Make the good decision. Well, if you look very closely, guys, I got it right away. If you look, that's a negative 4x and that's a positive 4x. Will that cancel? Yep. Let's start there. So we're going to take equation A and equation C. A plus C. A is negative 4x minus 3y equals 0. C is 4x minus z equals 12. We can add this right now. We already have our additive inverses. The x is going to cancel. Watch yourselves. This is where the common mistakes come in. I know I lined the y and the z underneath each other, but are they like terms? Will they cancel? No way. You write them in alphabetical order. Negative 3y minus z equals 12. Now, we got to do the same thing. All righty? We got A and C together. We got rid of the x's. Now, can we get rid of any more x's? Well, we got a problem. A and C are the only equations with x's. So we're going to have to now find another equation to put together. We don't have any x's to get rid of, so what do you want to get rid of now? So we have the A and B, or we have B and C. What do you want to do? Well, do you have opposites anywhere? Well, if you look, A and B have the three y's that are opposites. That's negative 3y. That's positive 3y. So that would cancel, correct? All right, let's do that. So let's take our A equation, and let's take our B equation. I'm going to line the 3y underneath the 3y because that's like terms, plus z equals negative 1. The x is going to stay. The 3y's are going to cancel. The z is going to stay. And 0 and a negative 1 make a negative 1. Now, everybody look closely. We're going to have to do something. Do you know what we're going to have to do? Well, this has a y and a z, and this has an x and a z. So do you see you have to eliminate the same variable? If you do not eliminate the same variable, you won't get the same result. So that didn't work. This is not going to work because we're not able to eliminate the same variable. And I did this for a reason, because I want you all to understand, I understand this is going to be very frustrating. You know, you may not get it right the first time. If we put A and C together, I agree, A and C were a great choice to put together because the x is canceled right away. But it didn't, when we eliminated that x, there were no other equations that can eliminate x. And you can't have equations with two different variables to work. So what we're going to have to do is go back to the drawing board. That did not work. The goal is to get two equations that have the same two variables. So because the x's didn't work, we're going to have to try something else. Everybody look. What else can we put together that would eliminate? Eliminating the x's and the y's didn't work, so what's left? Well, can we eliminate the z's? Sure we can. If you take equation B and C, won't the z's cancel? So let's take equation B and equation C. And if you look, if we add them, the z's are going to cancel. We have 3y and 4x. We'll write it in numerical order. 4x, that's plus 3y. And if we add negative 1 and 12, we get 11. Now, why did that work? Because everybody look very closely up there. Do we have an equation that has x's and y's we could put this with? We do now. Can't we put it with equation A? Equation A has x's and y's, and now this new equation has x's and y's. And that's the goal. When you're doing this method with a system of 3, you must get an equation and get it down to two variables. But there's got to be another equation with the same two variables you could put with it. So the first go around, we didn't do anything wrong, we just didn't get what we wanted. We didn't get two equations with the same variables. But now by putting B and C together, we have x's and y's, and look at equation A. Equation A, we can line up right underneath this and put it together. And add this up, because we have opposites. Well, that cancels, and the y's cancel, which makes 0. And on the right side, 11 plus 0 is 11. Uh-oh! What happened, guys? Little Bo Peep has lost her sheep. Yes, even in a system of 3, you can lose your variable. Well, if you lose your variable, we're back to that same old idea from Module 1. Is this statement true or false? 0 equals 11 is false. And what is the solution always to a false statement? That's right. There's no solution. So, the moral of the story is here to be patient and not get frustrated. You'll always have 3 equations. Your job is to pick 2, put them together to eliminate a variable. Pick 2 more, but you got to eliminate the same variable. You've got to end up with 2 equations with only 2 variables, but they have to have the same to get to a solution. Okay, we have one more module in this chapter. See you in a little while.